You are listening to Talking Machines, the show where we learn more about machine learning. It's all in the name. You don't really need much more explanation than that. I'm your host, Catherine Gorman, and I am here with my co-host, Ryan Adams.
Hi.
This is our first episode, and we wanted to take a little bit of time to introduce ourselves and also what we're going to be doing here, and give you a little taste of the things that you're going to get to listen to this season. I am a interested non-expert, which is code for nerd who has no credentials, and I just really love learning about machine learning and how it's going to shape literally everything in our future. I'm pretty convinced at this point. But Ryan, you are actually an expert in this field. Tell us who you are.
My name is Ryan Adams. I'm an assistant professor of computer science at Harvard University. I'm in the School of Engineering and Applied Sciences. There's actually not a computer science department as such here, but
Really?
kind of a school of engineering with a lot of different kinds of things like applied math and applied physics and electrical engineering. And computer science is a big part of that, and that's the group that I'm associated with here. My main research focus and the focus of my group is on machine learning. Machine learning is a really exciting area. It's a subfield of computer science that interfaces with statistics and artificial intelligence and physics and lots of different interesting areas. The gist of it is basically to try to figure out how to make computers learn from data and learn about the world and learn from experience broadly defined so that they can help us do interesting things. Maybe they can make predictions for us. They can do things like help us make decisions and generally find maybe new representations of complicated data in the world that we can then better understand. So maybe things like better search engines, better scientific visualization, better predictions about the weather, and all kinds of different kinds of things. I think the best way to think about machine learning, or at least one interesting way to think about machine learning, is as a way to automatically write computer programs. So the typical way that you might write a computer program traditionally is you sit down at your computer and you write a bunch of code and you imagine different kinds of inputs that program might see, and then you think real hard and write down a way to take those inputs and produce an output.
Right.
And machine learning is a different kind of way to do programming in a sense, in which what you do is you first sit down and you assemble a bunch of examples of inputs and outputs, where if I had this input, here's what I'd like to produce.
Right.
And a typical kind of example might be something like, oh, here's a picture, and I think this is a picture of a dog, and I'd like it to produce the label dog, given that such an image. And here's another one, and this one has a cat in it, and I'd like it to produce the label cat instead of the label dog. And then maybe I get hundreds or thousands of examples of images like this, and I present them to a machine learning system, and it gives me back a program that, given an image, can tell me whether or not it's a cat or a dog or something else.
Right.
And it's a certain kind of automatic programming at some level, where we give it lots of examples of something and maybe some notion of what the right behavior is, and it tries to learn to get good at that for examples it has never seen before.
So you're letting the computer do the thinking real hard part.
Well, hopefully. I mean, this is why we call it learning. So humans kind of do this too. As a little kid, you see examples of what looks like a dog, what looks like a cat, what looks like a horse and a cow, and so on. I have a toddler at home, so we do a lot of this, identifying animals and things. And so what we're trying to do is develop a way for computer programs to do this same kind of thing. And this is why it's really related to the field of artificial intelligence. And why we often think of it as a subfield of artificial intelligence, because AI can mean a lot of things to different people.
Oh, yeah.
And, maybe it's making, smart decisions and kind of, voice recognition or a lot of different things. But it's hard to overstate the importance of adaptation to intelligence, I think. That anything that's really intelligent is going to be interacting with the world and adapting and responding and learning about the structure that exists. I think right now, trying to figure out how to do that in intelligent systems, how to make intelligent systems learn, is one of the most important and exciting scientific questions.
Oh, definitely.
But as I said, it also relates to sort of things that maybe have less science fiction appeal, but things like statistics.
Yeah.
Because a lot of what learning really means is understanding the way that the world works, and that means understanding the way that the world works statistically.
Right.
Like, what is it? A lot of what makes something intelligent is something's ability to see sort of signal in the noise, that the world is uncertain. There's a door over there. I don't know what's on the other side of it. But something that's intelligent, maybe can reason about what's on the other side of that door, even though it can't see it. And this is an inference problem, right? This is a question of how do I disambiguate all of the uncertainty and the noise and sort of understand what's going on. And so a lot of the tools and a lot of the mathematics that we use for this in the field are fundamentally statistical. And as a result of this, then there's a lot of crosstalk these days between the statistics and machine learning communities.
So there's a lot to unpack here. Everyone is starting to use these techniques to sort of look at their own data sets and find new ways to think about them and approach them and get different answers out of them. So every 2 weeks, we're going to bring you a new episode. Ryan and I will be discussing a little industry news. We're going to be having interviews with experts from all sorts of different fields who are using machine learning for all sorts of different problems. And, every once in a while, we might even try to answer your questions about machine learning problems or your own data sets. So we'll see how that goes. We're going to attempt that. But a couple of weeks ago, we got to go to NIPS, which was really exciting. We hauled up to Montreal. And NIPS, I should say, is the Neural Information Processing Systems Conference. Is that correct, Ryan?
That's right.
And Ryan, I heard you a couple of times describe this conference as your home conference. So can you give us sort of a feel for what NIPS is like for you and the rest of the machine learning humans?
Sure. So there are a couple different big conferences in machine learning. And generally, the two really sort of best-known ones are the International Conference on Machine Learning, which is ICML, which happens every summer, and the Neural Information Processing Systems Conference, or NIPS, which happens in sort of first or second week in December, and is almost always in somewhere cold because it's almost always been associated with skiing. Although that's
not this year.
Not this year.
It was just cold this year.
Yeah, it was just cold. But for the first time, it wasn't anywhere you could easily ski. But it was in Denver for a long time, and then more recently in Vancouver. In the last couple of years, it's moved around a little bit before landing in Montreal. And I should say there's a couple of other great conferences too, AI Stats, UAI, and some in a new conference called iClear. But I think of NIPS as being my home conference because it's sort of the one it's the conference that I went to first when I was a grad student. It's the one I try to make sure I go to every year. It's the one that I think my closest friends in the field also always try to go to. So I think it was my home conference because it feels like a family reunion in which I get to see all my friends, whether or not we're presenting work, and we get to hang out. And it kind of maps well onto at least like the winter holidays where you go home for Christmas time and you like go to the bar and there's
everybody from high school.
Everybody from high school, and you chat up all your friends from high school and see what they've been up to. It's like that, but for grad school.
Good, nice.
So you like turn up and there's all your old grad school buddies.
There's everybody from my postdoc, and we hang around and get drunk and complain about our parents, which is your principal investigator.
Exactly. That's exactly right. You got to catch up on all the gossip. What have people been up to?
So I had a great time as someone who was just running around at the conference, but we got to talk to a bunch of really interesting people while we were there. We cornered a bunch of people for interviews. It was really fantastic. The first part of the first season, we're going to be bringing some of the interviews that we got a chance to do at NIPS, and we started off by cornering Kevin Murphy. Can you tell us a little bit more about Kevin and what the sort of work that he's doing there now?
Sure. Yeah. So Kevin is great. So he was at the University of British Columbia for quite a while and got tenure and did some great work there, but then has more recently moved to Google in Mountain View. Kevin spent many years writing a textbook that came out now, I guess, in maybe 2010. And this book,
it's one of the most popular textbooks in graduate courses on
absolutely.
Machine learning.
It's the textbook that I use in my course. It's the textbook that I think a lot of people use. It's, I think, the most comprehensive sort of graduate level text on the market right now.
Yeah. And when we got to sit down with Kevin, we talked a little bit about his textbook and also how you write a textbook for a field that changes so quickly. So, let's take a little listen to that interview.
Switch tracks a little bit. You recently published a textbook.
I did.
And I was researching a little bit, and there's a Reddit about your textbook. And the first the first question is which I am trying to read Kevin Murphy's textbook, and I can't get into it. What do I need to know to be able to understand Kevin Murphy's textbook? So, Kevin Murphy, what do I need to read to be able to understand your textbook?
Oh goodness. Well, it's designed for mostly graduate students and maybe senior undergraduates. So people who have, suitable mathematical training, who have maybe, taken a basic class in probability theory and linear algebra, and have some comfort with programming in, Python or some language like that. So, there are lots of other books that teach these more basic things. There are more gentle machine learning books out there. Are you asking me to recommend some?
Yeah. What do you think would be a good basis for getting into machine learning?
Oh gosh, I mean, the field changes so fast. I don't remember the name off the top of my head. I mean, I look at my Amazon reviews, and some people have said that my book is inaccessible. So I know one thing that's popular, at least on Amazon, but I haven't read it myself, is the book by Abu Mustafa, who's a Caltech professor, and that has high ratings. So if you trust Amazon's rating system, that might be a good entry point. It's certainly shorter than mine, which has virtues. I should point out, however, for those of you listening, that I apologize for all of the typos in the first version of my book. It went to press rather quickly, and so if you have an old copy, it does have quite a few errors, and I'm sorry for that. The latest printing is the 4th printing. It's been quite popular, so they're up to round 4, and most of all the known errors have been fixed. So it should, I don't want to say it's flawless, but there are very few errors now, I believe. And I'm hoping actually to work on a second edition. MIT Press has asked me to start thinking about that. It might take a couple of years, so don't wait for it. But eventually, the field is moving fast, like I said, and I realize my book is like a de facto standard now in many classes. So I would like to keep it up to date.
So actually, sort of related to this, I mean, one of the challenges in a very fast-moving field is, of course, deciding when you're going to stop and write the book and kind of where the horizon is. One of the things that makes your book really remarkable and really great from my point of view for trying to teach a graduate course that gives a reasonable snapshot of modern machine learning is that it sort of references papers and ideas that are quite recent. And this is in contrast to other good books, for example, Chris Bishop's book that sort of stops at, that was written in maybe 2006, but that in a sense was complete from a technical point of view in sort of 2000. So how did you grapple with this decision of where to draw the line on what to include?
That's difficult. I should pay homage to Chris's book. I taught classes from it myself for several years, and I learned a lot from it. But yes, it was the fact that it was somewhat out of date that was a motivation for me to write my own book and to try to bring some more modern material in it. It's very difficult. Like I wrote a chapter on deep learning, and that's one of the fastest moving subfields of machine learning, and it's already significantly out of date. So that's one of the things that I hope to update in the second edition. But there are other topics that I didn't have space to cover. So stuff that Ryan works on, for example, with Bayesian optimization, didn't make it into the first edition. And at the time, it maybe didn't seem that important. And recently, I think its value has become apparent. Similarly, reinforcement learning, I made a conscious decision not to cover it because it was, I think, considered somewhat fringe. And recently, I think there's been a lot of breakthroughs in the field, partly due to the DeepMind guys in London, but some other groups as well. And it's, of increasing importance, I think. And it's not covered in any of the other books. So it's just my gut instinct about what's important. Like at the time I wrote it, I was a professor at the time, and I was writing what I think the students ought to know. It was kind of like the field guide to surviving NIPS and getting your thesis at a top school. Like, what do you need to know? You pretty much need to know everything in that book, and other things too. It's not encyclopedic, but I was trying to be as broad as possible.
So yeah, that's just a part of the interview that we have with Kevin Murphy. We got to talk with him about the complications of publishing in machine learning and what his hopes are for his next textbook that he's working on, and also his own research, what he's got going on right now. So you'll be able to hear that whole interview with Kevin Murphy coming up a little bit later in the season. So while we were at NIPS, we also got to sit down with Hannah Wallach. And Ryan, she's one of your close friends, actually.
That's right. Hannah is one of these people that I really, that I go to NIPS to see. She's a close friend. We went to graduate school together at the University of Cambridge and both worked with David Mackay. Since then, she's gone on to do lots of other cool things. She's currently at Microsoft Research in New York, and she's on leave from the University of Massachusetts Amherst. Hannah, like I said, does lots of neat things, both from a purely technical point of view in machine learning. She's done a lot of really neat stuff with topic modeling in particular. but she's really at the forefront, I think, of somebody who takes machine learning tools to do quantitative social science, to try to understand political systems and to understand sort of social processes using these quite sophisticated probabilistic models.
So when we sat down with Hannah, we got to talk about the research questions that she's grappling with right now, which really focus on the roles of people in local government, which I just found absolutely fascinating. But we also talked a little bit about how she was instrumental in starting WIML, which is Women in Machine Learning. It's this co-located event, workshop. What would you call it, Ryan?
I think it's fair to call it a workshop.
Mm-hmm. So it's a co-located workshop that happens every year with NIPS, and it's a chance for female researchers to present their the technical side of what they're working on. And she told us a little bit about how the event got started.
As I said, I've been to NIPS many times. And in 2005, I finally knew other female PhD students. And as a result, I was able to share a room with them at NIPS. And this was pretty shocking. So we were hanging out in our hotel room and we were sitting around talking.
Who was it?
There was me, Jen Wortman, Lisa Wayner, and Angela Yu. And I think actually in that conversation, Catherine Heller was present as well, and maybe some other people. But we were basically hanging around and just talking about the fact that it was amazing that there were so many of us. You know, there were 4, 5. This seemed like a huge number. And we got to talking and we started trying to think of other women in machine learning. And we got to a point where we had thought of 10 women in machine learning. We thought, this is incredible. There are 10 of us. And so we thought, maybe we should do something to bring them all together. So the idea that we came up with was to submit a proposal to the Grace Hopper Conference, this annual conference that is focused on women in computing. And we did exactly that. It ended up being me, Jen, and Lisa who ended up doing this. We submitted a proposal. By the time we submitted our proposal to Grace Hopper, we had a list of 25 women in machine learning. And this just completely blew our minds. There's an email thread between me and Jen in which I think it's me who says this in all caps, there are 25 women in machine learning. This is incredible. We just thought this was shocking, amazing, totally awesome. So we submitted our proposal to Grace Hopper for various reasons. It ended up not happening as a session at Grace Hopper, in part because what we'd proposed was much bigger than what Grace Hopper sessions typically are. So we decided to go it alone and to co-locate a separate standalone event the day before Grace Hopper that year. So that was 2006 by that point. So Jen, Lisa, and I then spent several months working really frantically to pull together the first Women in Machine Learning workshop. By the time the workshop happened, it had grown way out of proportion beyond whatever we'd ever thought we might have. We had something like, I don't remember the exact number, but it was around 90 registrants that first year, which was just unbelievable to us. The workshop was a huge success, really amazing talks, amazing presentations from a really interesting group of people. And at the end of the workshop, we had a discussion trying to figure out where to go from there. And it was decided that we should hold another one of these the next year. So we recruited some other organizers because we were pretty burnt out at that point. And the workshop was held again in 2007 and again co-located with Grace Hopper. By that time, we'd started to get money to bring participants to the WIML workshop. We started doing some serious thinking about what we wanted to do moving forward. We ended up realizing that if we were instead to co-locate with NIPS, which is kind of where this whole thing started anyway, that we would be able to dual purpose our funding by not only using our funding to bring women to WIML, but that would then enable them to attend NIPS.
Oh, that's great.
Yeah, so we
really
ended
cool.
up then working with the NIPS Foundation Board to co-locate WIML from then onwards with NIPS. It's been at NIPS since, I guess, 2008. We hold it the day before everything starts. I guess it's actually on the same day as the tutorials because people didn't want to come. NIPS is already a very long conference.
That's right.
People didn't want to come for an additional day. But we hold it before the main conference starts, so that women get a chance to get to know one another, so that then when they do attend the main conference and they're in that sea of 2,400, 2,500 people, they at least recognize a few familiar faces. And this seems to be working pretty well.
That's fantastic. So how big has it grown? How many people come to WIML now?
So I can sort of answer that question and sort of not answer it, and here's why. This year we had 160 registrants, but we explicitly capped registration at 160 because we ran out of space. We had no idea it was going to be.
It's a good problem to have.
Exactly. So I can concretely tell you that 160 women registered. What I can't tell you is how many more would have registered had we actually been able to accommodate more people.
So coming back here to Montreal next year, are you going to be able to expand it?
Yes, we believe so. And one thing that I actually want to take this opportunity to mention is that right since its first year, we were hoping that WIML would serve not only as an opportunity to bring together women from the machine learning community and to kind of promote and support their work, but we were really hoping that it would serve as an opportunity to showcase women's work to the wider machine learning community. So we've been thinking a lot about this over the past, 9 years or however long it's been. And every year we do have a small number of men attending the workshop, but we've begun to realize that men, for the most part, don't realize that they can attend.
That's right.
So what we'd really like to do is actually see more men attending WIML next year. They won't be presenting their work because it's intended to showcase the work of women in machine learning.
That's one of the things that people need to realize too, is that it is a technical
that's
workshop.
Absolutely. It is focused on technical discussion, technical talks. So we have a number of invited speakers who are women presenting their technical work in machine learning. We have a number of students presenting their technical work. We typically have some kind of mentoring session and some kind of career session, but the bulk of the time really is devoted to that showcasing of technical work. And so we're really hoping that more men will start showing up to WIML to really get more of a sense of the amazing work that all of these women are doing.
So it was really fascinating to talk with Hannah, and we will bring you the full interview with her a little bit later in the season, and we'll dive really far into her research, which is really fascinating. One of the other people we got to talk to while we were at NIPS was Professor Max Welling, who's the 2013 program co-chair for the conference. And something kind of crazy happened at the 2013 conference. Mark Zuckerberg just showed up in the middle of it and was like, "Hey guys, what's up?" So Ryan, you were there. How did that affect the conference?
Well, so I didn't actually see him at the conference
you just
myself.
Heard that Ryan Gosling was there.
Exactly. It was the only thing anybody could talk about. It seemed like. Well, so first at NIPS, there's the main conference, and then there are 2 days of workshops, and the workshops are, there's a bunch of different workshops on different topics. One of the very popular workshops for the last couple of years has been the deep learning workshop, as deep learning is sort of taking over the world. And one of the ways in which deep learning has been taking over the world has been that it's getting huge investments from really big tech companies. So places like Google and Facebook and Microsoft and so on. And one of the challenges, though, has been trying to recruit really great people and get research labs started up at places like Facebook to do research in this and to take advantage of these advances. And Mark Zuckerberg made an appearance at the deep learning workshop.
Yeah.
And I think he was on a panel and answered some questions. And by all accounts, really had very interesting things to say about how Facebook would like to, I think, sort of build a theory of mind to understand the way that people are using it, understand what's going on, and be able to, help them communicate with the world, and probably also present them with better advertisements based on kind of an improved understanding of their psychology, and that this will necessarily involve a lot of machine learning. The effect on the conference was interesting. It was the first NIPS where it really felt like there was a lot of industrial sort of commercial attention. NIPS has been this kind of funny community that does its own thing, and it's kind of quirky with the skiing and all, and it's this big but single track conference and so on. And like I said, it kind of always felt like a family reunion for me, even as it's gotten bigger. Last year, suddenly it felt like there was a lot of money, and the stakes were very high in a way that they hadn't been previously. And that's so on one hand it's really great because you feel like this indicates that there's a lot of attention. You like the things that you're working on to be important.
Right.
You like people like Mark Zuckerberg to care about the work that you're doing.
Definitely.
On the other hand, it causes the incentives to change.
Yeah.
In complicated ways, and I think we all feel a little bit ambiguous about that, and I think that's something that that Max articulated well in when we chatted with him.
Interesting. I'm interested in that relationship between academia and industry. So what we have seen is that the big internet companies in Silicon Valley have attracted a lot of our talented students. Basically, my students are immediately absorbed into these companies, and they are doing very good high-level research, and they have the resources, and the data, and the compute power, and so a lot of the really best research is coming out of these labs now, and they actually also participate in the academic process, so that they also, organize conferences or donate money, or so they, there's really a two-way street, which I think is very good. And we are also seeing a dwindling of funding from governments, which worries me. But for us, maybe if we can sort of get industry interested in, in also providing funding for research, since we are, delivering their workforce. I think that could be a very interesting relationship that we should explore.
How have you seen it evolve over the past 5 years? It seems to have changed so greatly, so fast.
Yeah. So one thing that I've seen is that university labs, they have startups because they have, first of all, they have interesting products or interesting ideas, interesting algorithms. And they have a lot of, they're sitting on a gold mine of talent. And these spin-offs get bought by bigger companies who then sort of build maybe a lab around it that's supported by that company. We've seen it in Oxford now. This could be a model for the future, right? So in some sense, maybe industries need to think harder about, if they want to commercialize whatever their ideas are, because they have lots of ideas and they publish them, but if they, these may be actually, ideas that could be interesting to industry. I don't know, there's pros and cons to this process, because if you get companies involved, of course they want the IP, and, what does that mean? Does it restrict other people to use what you did? And so these are interesting questions that we need to ponder and explore in the future. I think the best thing, of course, would be that the governments would fund fundamental research again at a higher level. But if that is not happening, maybe we should explore other things as well.
Do you see the decline in funding as a global trend? I mean, it's very prevalent in the U.S., but
and it's also very prevalent in Europe.
Mm-hmm.
Maybe less so in Asia. But I'm not living in Asia, so
right, exactly.
I cannot profit from that. But in Europe and in North America, this is definitely a trend, and it worries me because it's having good research is very important for economy. I know I'm hoping that trend at some point will turn around, as the economies will get stronger again. But yeah, up to that time, we'll have to maybe also find other alternatives. And I should say that I'm also interested in working with industry, as I said, because sometimes they have the interesting problems, they have the interesting data, they have the resources to work with that data. So there's also certain advantages to having access to that in a big company.
Mm-hmm. In academia, there are very sort of set ethical rules and patterns of behavior that you must follow. Do you see those things translating into the corporate realm of research, or are we going to see new developments along those lines for corporate basic research as well?
I think the game will change a little bit. If companies get involved, some companies are better than others. So in academia, we have everything open. We like to publish everything immediately, and we like to have our code accessed by everybody, basically open access. If companies get involved, you pay a price, and the price is that they will want the IP. And I think what will not change is that whatever gets done gets published, because the work is mostly done by PhD students and master students, and they need to publish their work. So that will not change. But maybe It will be delayed by a little bit, which you don't think is a problem. But you could worry about the IP question, how that develops. So it's something that needs to be experienced and figured out. And I don't think the last word's been said about it. But I think it's at this point neither super positive nor super negative. It's a new relationship between academia and industry that has pros and cons, and that needs to be explored. That's the way I see it.
So it was really interesting to talk to Max and get his perspective on how industry's involvement in the field is sort of changing things and how that might develop into the future.
Yeah, I'm so glad we got to talk to Max. He's such a thoughtful guy. And I have to say, I think of him as being one of the most creative researchers in the field of machine learning right now.
Oh, definitely. And while we were there, we also pulled off sort of a Hail Mary, and I didn't know that if we were going to be able to do it or not, but it was really fantastic. We got to sit down with Jan LeCun, Geoff Hinton, and Yoshua Bengio, and it was really amazing. We got them all in the same room for like an hour and a half. I couldn't believe it. So we should sort of step back and explain a little bit about who these guys are and what they are doing. So Geoff Hinton is at the University of Toronto and also at Google. Jan LeCun is at Facebook and also NYU. And Yoshua Bengio is with the University of Montreal still, yes?
That's right.
And these three guys have been around since the beginning of machine learning.
Well, I think it's not fair to say the beginning of machine learning, which we could probably draw sort of, a line back to at least the 50s for machine learning.
They're not that old.
They're not that old, but these guys are definitely pillars of the field. And one of the things that's so fun about getting to talk to them also in the same room is that they have such a great long view on machine learning as they've made contributions over decades. And in particular, the thing that's most exciting right now is that they're really leading the charge on deep learning,
right?
This resurgence of neural networks that's captured the attention of so many people. These guys basically invented that. This idea that sort of started in 2005, 2006 of really revisiting neural networks for hard problems. These guys own it. They even in their own words they said that it was a conspiracy to get people excited about neural networks again. And it was really fun to get them in the same room.
Definitely. And when we sat down, we first asked Geoff for sort of a long view, his sort of historical take on what things have been like for him in the field.
So in the 80s, we had a very exciting time after a number of different groups discovered the backpropagation algorithm, Jan being one of them. And in the mid-80s, we thought this would do wonderful things. And we managed to get it to do some pretty impressive things for reading handwritten characters, and fairly impressive for speech recognition, where it was about on a par with the existing best technology. But it was a disappointment overall. We couldn't learn lots of layers of features. And so the whole idea of deep learning is you want to learn layers of features instead of hand engineering them. And pretty much the only system where that worked really well was a system for handwritten character recognition that Jan developed at the University of Toronto and then later at AT&T. And that was used widely, but it wasn't enough to keep everybody interested. And in the 90s, other machine learning methods that were easier for a novice to apply did as well or better than neural nets on many problems, and interest in them died. The three of us all knew they were ultimately going to be the answer. And when we got better hardware and more data and a slight improvement in the techniques, they suddenly took off again.
It was really fascinating to hear what Geoff had to say about how the field has developed and where it's going. And Jan also had some really interesting ideas about computer vision specifically and how it's changed and how rapidly it's changing.
That's right. Yeah. Jan's a lot of Jan's motivations over the years, I think, has been to get really good at different kinds of computer vision problems. But some of the technical approaches that he's had, convolutional neural networks and related ideas, have come in and out of fashion over time. And sometimes that's been frustrating, and other times it's been very exciting.
I consider myself an integral part of the vision community. I started, going systematically to CVPR. I was actually program chair of CVPR in 2006. It wasn't like a war of the deep learning people against the computer vision community. I consider myself part of it. But trying to convince people there that eventually people will use feature learning because that was the obvious solution. And it went against a very ingrained kind of philosophy in computer vision where a lot of people there build a career around the whole idea of building features. But there was one kind of surprising change of opinion in that respect, which is a gentleman called David Lowe, who is at UBC in Vancouver, who is the inventor of the SIFT feature extractor, which is extremely popular in computer vision. And there was an interesting workshop 3 years ago at the MIT on the future of computer vision, where all the computer vision community, got together and said, where is computer vision going for the next few years? All the, program managers for funding agencies were here, everybody. And David Lowe said, the future is feature learning. This is, the kind of stuff Jan is doing, and convolutional net, that's the greatest thing. He'd done a little bit of work on this. And there was a whole session on deep learning. Rolf Fergus kind of gave an introductory talk, and Druin gave a talk which didn't go very well at all. Was not really sort of received well by the community. And I gave a talk, and the title of my talk was, in 5 years, all of you will be learning your features, you might as well start now. I was wrong, it only took 3 years. So what happened was that the evidence was there that those methods were working. And working better than a lot of techniques, but they were easily dismissed by people who could say, "Oh, this is an isolated example. It's just that we haven't tried hard enough with our methods, with the other methods, and so it's not definite." But the results of the Jeff's team, the ImageNet 2012, was so overwhelming that there was no discussion anymore.
I think it really is fun to see your ideas win out in the end, where you think hard about problems and you care about problems and particular technical approaches, and then to see those things really carry the day. It must be very, very exciting.
Yeah, but definitely. But none of this, it seems, in talking with them, none of this has come easily. And Yashua had some really interesting things to say about staying with your convictions and really keeping faith in your ideas even when they might be unpopular.
That's right. And Jan and Jeff had interesting things to say about that too.
From the historical perspective, something really important happened, which is that a few people, Jeff, Jan, I, and a very few others, stuck to their vision of what they really believe was the right way of doing things. And it's not easy to do that. You go against the fashion of the day, and it's easy to also go wrong in this and stick to your ideas and not look at the evidence. But I think for research, for long-term research and real breakthroughs, it's really important to look deep down, and if you really believe in something and you have a strong intuition about it, of course the evidence is always important, but you may need that strong feeling to carry through difficult times and patiently continue to understand what is going on and demonstrate your ideas. I think that's one of the most
It's okay. No,
that's one of the most important lessons for young people who are wondering what to do and how to decide what in which direction to research.
So there are sort of a human component to this, which is what happens to students who embarked on the this sort of quixotic quest of their advisors. So I started being an academic in 2003, which means my first batch of students graduated around 2008, 2009, 2010, and it was also the time of the sort of economic crash, essentially. So there were no jobs for them, no jobs in academia for sure. Universities were not hiring. Deep learning was really frowned upon as a field, and so none of those people who are excellent got jobs in academia, and in fact many of them had trouble getting jobs at places like Google and things like this, which hadn't adopted the philosophy yet. They got pretty good jobs at NEC, SRI, and AT&T and places like this. But in the last 2 years, it turns out they were the only people who knew anything about neural nets, who had a little bit of experience, perhaps even were managers in their group, and had sort of the early papers, and they're all millionaire now.
Right.
And you'd have thought people would have learned, but we're now working on the next good idea, and the same problem is arising. So I've got a couple of very good students who've done their theses on the next good idea. One of them got a job at Google, but mainly because he managed to port the speech recognition system to them. And the field just never learns. Everybody now, you can publish any papers you like on deep learning. But if you say, well, there's something deeply wrong with deep learning and we need to change the way we're doing things, it's impossible to get them published.
It was really fascinating to sit down with all three of them and get to talk and also get to hear them in conversation with each other about the field.
Oh, it was such a unique opportunity. I mean, to get all those guys in one spot and be able to take up their time in that way.
Yeah, definitely.
Well, it was very generous of them and really a lot of fun.
And we've got many more really interesting conversations coming up for you this season. You'll be hearing the entirety of Hannah Wallach and Kevin Murphy and, of course, the big three.
Oh, and plus lots more fun people, too. I mean, we talked to Neil Lawrence and we talked to Charles Sutton and just lots of there's so many thoughtful researchers. And,
definitely.
And luckily, a lot of them came to NEPS, so we got to have a lot of really interesting chats.
Yeah, David Bly is starting his own department at Columbia. How do you do that? And we even get a chance to talk with David Mimno about zombie ghost princesses and how he's using machine learning to study their relationships to the evil barons who take over their castles.
Can't wait to hear about that.
I know, it's going to be so great. So we hope you'll tune in for the rest of the season. I'm Catherine Gorman.
And I'm Ryan Adams.
And we hope you'll join us again for Talking Machines.